Okay, are we viewing my title slide?
I can see it, yes.
Okay, very good. Well, thank you very much, Marco, for putting this together. I've been working on JSON-LD pretty much since the beginning, and I think it's really come quite a long ways, and it exists at an interesting point in the linked data ecosystem, as for many people, the fact that it's a linked data standard is somewhat beside the point. Brief history, work on JSON-LD started actually, Mark Burbeck had proposed something called RDF-J in order to provide a means of expressing RDF in JSON. This came on the heels of work on RDF-A 1.1, which is RDF and attributes used for HTML, which is still, of course, quite in quite wide use, but had a number of frustration points for people. So as JSON was emerging as an important standard for data interchange, specifically for APIs as an alternative to XML interfaces, I guess in retrospect, it's rather natural that we would then look to see how to use that as a carrying point. JSON itself, notably, is quite simple with only a few different types of data types, and notably does not have any kind of a data type to represent a URI. So thus, a lot of work has been done to bring it around to be able to express these things. Also notable at the beginning was work by Mano Sporny, who has done quite a lot of work. And at the end, I'll have a reference to the JSONLD.org site where you can find many different presentations. This presentation in particular is not intended as an introduction to JSON-LD, or for that matter to JSON, but you will find many resources there, including some nice videos where Mano goes through the precepts. Sufficient interest came along that we formed a community group, which is when I got involved, as well as many other people, including Marcus Lanthaler, who was the third editor on the 1.0 specifications. And after some back and forth, it was adopted as a work item by the RDF working group, which was somewhat contentious, as JSON-LD really set out to not, it was definitely based upon the RDF data model, but the proposition was not specifically repealed to RDF people, but rather to people working with JSON otherwise. The idea being that JSON itself has only as much meaning as is conveyed by the API documentation you might be using. Perhaps a developer is using it as a way of communicating information to a web page, or it's used as a way of accessing a remote site. But because it only supports the notions of objects with properties, arrays, strings, and other primitive types, to know what these things mean, for instance, the property name, you might guess what it means, but in RDF, we want to know absolutely what it means. So we wanted a way, of course, to be able to turn that name property into a URI, such as schema.org/name. So JSON-LD was intended as a way of adapting to the norms of expressing JSON while allowing a means of giving absolute, unequivocal interpretation to what the data means. We later published the 1.0 recommendations, which are, and I just looking at the wiki page yesterday, the Wikipedia page on JSON-LD still references the 1.0 recommendations. We have, of course, worked subsequently on 1.1, which we'll get to here. But 1.0 recommendations were never in doubt. As people have worked on standards, you know, these are things you invest a lot of time in and put it out there hoping to get adoption. In the case of JSON-LD 1.0, in no small part, the wide adoption it's received is due to the use by schema.org as a means of expressing information that search engines such as Google and Bing extract from web pages when they're crawling. And subsequently, it's made JSON-LD the largest by far means of expressing linked data on the web, although, as I mentioned, most people probably don't realize they're using RDF and don't particularly care about the RDF aspects of it, the linked data aspects of it, but it's quite important to the schema.org use case to be able to understand what people are meaning. There were some gaps in 1.0. It was capable of representing pretty much everything in RDF and allowed most expressions of JSON to be interpreted that way. But we found a number of shortfalls where there were some JSON dialects that weren't well covered to be interpreted as RDF the way you might expect them to be. So work began within a community group with some hope that perhaps a working group would be chartered. Got quite a lot of interest, and it was chartered in June of 2018. A JSON-LD 1.1 working group adopted the work of the community group, and of course didn't stop there. There's many more things that have been added we'll get into today, which led to this June, 2 years later, the publication of the 1.1 recommendations. And there's references there you can see to all of the recommendations, which are also available from the JSON-LD.org site. These, of course, are timestamped recommendations. You can find them easily enough by searching. Of course, JSON-LD syntax is a recommendation. My reference there needs to be updated. Example of use in schema.org, which is probably when most people encounter this, is using a script tag typed as application/LD plus JSON, which is the JSON-LD MIME subtype. In this case, you might have a web page describing a recipe, and previously that recipe might be marked up with microformats, later RDFA and microdata. This provides an alternate way of doing that with JSON-LD, which I think expresses the data much more succinctly. And for web pages which are automatically generated from a database, probably represents an easier way of inserting that data into a web page. In this case, we show it in the head matter of a web page, but of course it could be any place within a web page. In fact, there could be many different script tags that all contribute components of JSON-LD throughout the web page. But I think for many people, the JSON-LD is easier to understand than parsing RDFA or microdata out of HTML. So the basic value proposition is that we really try to adapt to idiomatic use of JSON. So looking at the types of data patterns people use for using JSON on the web and come up with a way of expressing them as linked data. The specifications favor the consumers and publishers of JSON-LD over tool creators. Consequently, you'll notice if you look at the JSON-LD API document, it is really more targeted towards people that are developing tools using JSON-LD rather than people that are either generating or consuming linked data, consuming JSON-LD. We do promote the soft use of, excuse me, of linked data principles. And many, perhaps most people that are using the data just see it as JSON. It just looks like a JSON that they might expect based upon the examples they see from schema.org without getting into the details of how you determine that something is a date or a URI. And of course, the means of differentiating URLs or URIs from text. So the way that this is done is using a context. So basically, context is introduced typically using the @context keyword, which then typically references a document. If you reference schema.org, that will actually use content negotiation to retrieve or formerly will have used content negotiation to retrieve a JSON-LD document that contains a context body that then describes all of the terms used and used by schema.org. Of course, context can be used inline, and it's possible to mix and match these. So a document might incorporate multiple contexts, either externally or represented inline. The last point on there, it's also possible to reference a context via an HTTP link header, which means that you can take a JSON that does not have an @context keyword within it, but infer that context by looking at the HTTP response. So basic syntax is it leverages an object. Typically, objects describe resources or entities. Properties relate those resources to values, often other resources. The values can be strings or interpreted as the context as other data types, or they can reference other entities. In the case of colleagues, those colleagues would be interpreted as URIs and might be URIs that are used elsewhere to identify nodes within the same document. For those of you, I'm assuming most people are coming from an RDF perspective, so I'll typically have a turtle representation of the JSON-LD. You can see what the equivalent RDF expressed in turtle would be. And just a note on that, JSON-LD, again, is not intended to be a competing format for turtle. I myself use turtle quite a lot for modeling data. It's a very natural language to author, but it's not always the easiest thing to interpret. And most programming languages can natively parse JSON into native data structures. And for most people, that's really all that's necessary to use the data. In addition to context, JSON-LD introduces some other keywords. These keywords can be aliased. So @ID, for instance, would introduce a node identifier type, a node type. These can be aliased to just @ID or type, which is commonly done. @value would indicate an object containing @value property represents some literal value, or list would allow an array to be given explicit order. Otherwise, arrays in JSON-LD are presumed to be unordered. Context looks sort of as we see here. It introduces a number of terms. For instance, schema term expands to a URI. Person term uses the schema term to expand that to schema.org/person. Colleagues uses a longer version of a term definition to expand to schema.org colleagues, but in addition, as I mentioned before, the @type means interpret string values as IDs. And same thing for images and URLs. There are a number of things that containers can be used to express how to represent array and sometimes object values. And they introduce some keywords, so you can use a container value of list to say, treat an array as being ordered, or set, have it treated as unordered. Similarly, language and index allow you to use objects that are index other values by language tag or an index. And in 1.1, we add some more container mappings. Additional things you can have in a context are specify default language. And we introduce in 1.1 the ability to have a text direction, something that was missing from RDF. We hope to introduce in the future. And scoped context, quite powerful feature we'll get into. So objects in JSON-LD basically attempt to utilize the JSON object notation as much as possible. And in general, an object defines what we would call a node definition. An object that only has an @ID can be considered a node reference. So because of embedding, nodes in this case might have been represented as an object that contained, say, @ID marcuslanteller.com, could contain other properties. When used just as an object, it's presumed to reference some other object in the same document. And arrays describe sets of things. So in this case, ingredients and nutrition represents an unordered set of things. In the case of nutrition, its value is an array, including a single node of type nutrition information. We can see here that pretty much wherever you can use a string, you can use an array of strings, or an object, you can use an array of objects. These all have equivalent meanings in JSON-LD, and sometimes it's preferred to use the array representation, as it makes the data a little bit more normal if you're accessing it just as JSON values. So working with data, JSON-LD provides a number of different algorithms described in the JSON-LD API. In this case, we see a Drupal example describing a Occupy Pristina event in 2012 that uses properties from a number of different namespaces. We can interpret what this means by applying the context or expanding the document using the defined context to get to an expanded document representation. In this case, all nodes are expanded. The individual values are represented as an array of values. URIs are in their expanded form, values are in their expanded form. For instance, the property for created might be described to have a type of XSD date time. This makes that explicit. And the expanded form then is used by other algorithms so that they have a normal way of working on data. There are 3 different specifications we introduced, the 2 of them in 1.0, JSON-LD 1.1 and 1.1 API. There was a JSON-LD 1.1 framing document, which was never a recommendation in 1.0, but was commonly used. Framing allows you to take a flat representation of nodes, an array of different node definitions, and cause those to be embedding using a program by example mechanism. We added a streaming note. JSON-LD is, because it's based upon JSON, JSON objects are unordered, it primarily requires you then to read the document into memory to be able to operate on it, so you know that you have all the node definitions closed and completely available. But sometimes data sets are open or quite large. There is a profile for publishing and consuming JSON-LD in a streaming way, which it requires a particular ordering of the properties in a JSON-LD object, so that we know we don't accidentally, or we don't have to defer the creation of triples until we've seen the entire object. There's a best practices document and a beginning of a note on representing linked data using CBOR as an alternative to JSON, using exactly the same data model. So the core algorithms are the expansion, which we went through, compaction, which is the inverse operation. You can, compaction is round trippable, so you take a document, expand it, you take the same context and compact it, you'll get back to exactly the same representation, which is a very powerful tool. It also can be used, and is more often intended to be used, to compact a document that you received with one context using a different context. And this can allow you to do this even within a web page if you, or in a client. If you retrieve a JSON-LD document, but you want to know that things are going to be encoded in its particular way, you can expand it and recompact it using your own context. Flattening a document removes the internal embedding and gets to a flat context, and also has the ability of creating a node map, which is important for framing. And then, of course, the ability to transform the JSON-LD, expanded JSON-LD, into the RDF abstract syntax, and similarly go from abstract syntax back into expanded JSON-LD, which then can, of course, be compacted or framed. So JSON-LD 1.1, I mentioned there's some frustration points. If you have a number of values, we do have a limited means of indexing them using, for instance, you have a set of strings that are all language tagged. There's the ability to index into those literals using their language tags or using a non-semantic index mechanism. But we wanted to be able to index into, say, nodes using their IDs or types. So we'll get into that. We typically expect all of the properties of a node to be defined directly as properties of that node. But if you look at JSON in the wild, often you'll see that there is a specific property, perhaps called properties, and the value of that, the node value of that, or the properties of that node, are then expected to be properties of the parent node. So we have a way of describing how properties can be nested to maintain that structure. One pain point was that to use the native list representation where you describe array values be ordered really only worked at one level, and we hadn't figured out quite how to do that in 1.0. That is corrected in 1.1, which is very important for specs such as GeoJSON, which use multiple levels of lists. And then the ability to embed context within a document, within a nested document, without using the add context keyword became really important as framing was used. So you frame a document. If it includes data from other sources, those often would be most naturally expressed with other contexts. So we have the ability to define the context to use when you are in a particular property or type context, a mechanism called scoped contexts. So we'll go into the various different contexts we introduce here, and at this point, we're going to be diving into each of these. It's going to look a little bit like a laundry list, but these are the core features added to JSON-LD 1.1. So as I mentioned, more generalized object indexing, the ability to have scoped contexts. This also allows you to determine how those contexts are propagated to subnodes. So for type scope context, for instance, that context by default maintains its scope only within that type is being used. If you transition out of that, you revert back to a previous context unless you specify otherwise. Recursive lists I mentioned. We also have the ability to name anonymous graphs. So we have, I mentioned container types that were added. So you can have node types can be, property types can be treated as nodes. They can also be treated as graphs, which is quite useful when you are using data sets where you are using something like a quoted graph. This is used, for instance, in verifiable claims to separate the thing that is being claimed from the claim itself. Property nesting, I mentioned, document relative vocabulary mapping. The properties in a node are determined to be vocabulary relative. So we actually have two ways of resolving relative URIs. If you see a property, typically you would expect that property to be associated with a defined vocabulary, whereas an ID would come from a document scope. If you think of an HTML document, the different IDs within that HTML document are all fragment identifiers of the base location of that document. Same pretty much true in JSON-LD. So we do have different spaces. JSON-LD 1.1 allows you to bind the vocabulary mapping to be based upon the document mapping, which allows us to do away with using blank nodes as the vocabulary base, which we'll talk about. We introduced the notion of protected term definitions. So if you define a term in one context, you can prevent a downstream context from overwriting that. Again, very important for things such as verifiable claims. Have the ability to import context to, say, take a 1.0 context and add 1.1 features to it. As you saw in the second slide, JSON-LD is used within HTML in a script tag. That was done using, without a standard way. Turtle had introduced a way of describing turtle blocks within HTML using a type with a type attribute. JSON-LD provides a normative means of doing that. That also describes how to deal with fragment identifiers, how to deal with context references that might be to within the HTML document, and how to treat multiple data blocks within an HTML document. We introduced the notion of JSON literals so that components of the JSON document are not interpreted. They are just kept as literals. This is analogous to HTML literals and XML literals. We support directional text, very important for internationalization use cases where when you're using something, say in Arabic, where the text is often not treated in a left-to-right manner, you can be explicit about that. HTML provides means of doing that, but there really is no other way of doing that in RDF in general. So we define a mechanism for that. It ends up content negotiation using accept header is difficult, particularly when static websites are in use. So many of you might have tripped over a change to schema.org lately, where instead of content negotiation on the accept header, there is a link header introduced, which has an alternate location, which is, if a JSON-LD processor sees that, the appropriate type, it will instead load the reference document. Big way to specify a set of nodes which are not otherwise related to the node that describes them. We abstract the specifications from JSON nomenclature. So there is an abstract representation based mostly on infra, where we map the JSON structures such as objects and arrays into more abstract data types, which then allows us to use the algorithms for all other formats such as YAML and CBOR that have a very similar data model. We introduced some ability to do more advanced frame matching, in this case on ID. And then we have deprecated the use of blank nodes for properties, something we had done in JSON-LD 1.0 because we did not want to require a vocabulary to be created in order for developers to use JSON-LD. But given the ability to use document relative vocabularies, it solves that use case, but still is in use by activity streams, for instance, so will remain around for the foreseeable future. So in order to prevent, since there are a number of processors out there are still JSON-LD 1.0, and it's possible that a 1.0 processor might misinterpret a JSON-LD 1.1 document, we have an explicit version announcement. So use at version 1.1, could really be any value, but in this case 1.1. A 1.0 processor that sees that will fail to parse the rest of the document. And of course, then you can encourage your developers to get on board with 1.1. And we've certainly seen quite a strong adoption since then. We introduced the concept of ID maps. So in this case, I have a property post, and I'm saying that treat the object value of post, instead of being a node object, treat it as being an ID map. So using at container ID. So here I have, and post will be an example that you would have seen in the 1.0 specs and the 1.1 specs. By the way, as an aside, I do encourage you to look at the examples in the specs. They are live examples and show all of the different ways that they are represented, but they also contain links back to the JSON-LD playground, which allows you to see them in operation and play with different values to see how they work. So if you were to do that here, you could see that this post example, where the value of post is an object, where the indexers are now treated as IDs, and the values of those are treated as node objects that have those IDs. You could see how that actually works when you expand the document. We have other types. We also, we can have type maps. So you might have an array of type things. And this becomes really useful if you are trying to look for all the posts that were, say, replies. You could have them indexed by type and then easily get to index into those different types. Then we also allow it for graph maps, so it's possible to index values by a graph ID. And we allow the key of @none or an alias of @none to be used to mean that there is no such value, but still can use this form of data. Scope context, here we have an interest term. Interest, it has a context within it. So the outer scope, we're in the schema.org vocabulary, and once we enter a FOF interest, then we transfer to the FOF vocabulary. So in this case, I use the name Monosporny, who has an interest of JSON-LD. If we look at the turtle, I can see that Monosporny's is in schema.org space. FOF interest reference a document where we're now using FOF name JSON-LD rather than schema name JSON-LD. So in this case, we're doing a property scoped context. We can also do type scoped context with alternative propagation, as I mentioned. Recursive lists, I think, are fairly intuitively obvious here. Say we have geometry with coordinates, which is a deeply recursive set of arrays, which will now go to the corresponding turtle. Graph containers. Graph containers are useful. JSON-LD 1.0 did have is a RDF dataset syntax, meaning that it has a default graph as well as 0 more named graphs. In 1.0, we can actually use use graph containers either to reference those named graphs, or in the absence of a name, it creates an implicitly named graph. In this case, we say we have an entity such as William Shakespeare who wrote something which we're going to now describe in a different graph. This will be an anonymous graph. Richard III of England said, "My kingdom for a horse." So looking at the trig now on the side, we can see that William Shakespeare wrote a blank node, and that blank node is also used as the name for that named graph. Now, those of you who know RDF 1.1 deeply know that those blank nodes aren't necessarily related, but I think colloquially most people will recognize them as such, and this is in line with the way that quoted graphs work in notation 3, if you're familiar with that. Nested properties are introduced. In this case, we can have, say, a property such as labels that includes a couple of different labels, and in this case, label and pref label, which allows me to group them together. So by specifying, in this case, labels as @nest, a processor will basically fold those contained properties back up. And I don't describe it here, but this is round trippable. So you can have a context related to this and compact it, and you will reintroduce that nesting. Document relative vocabulary should be fairly obvious. This is thanks to Kingsley Edaheen. I can describe a term which isn't described outside, but rather is described within the document itself. In this case, if I don't want to have a control vocabulary for a name, I can easily put it in the same namespace as the document itself. Protected term definitions, you can protect an individual term definition, or if you actually put it at the top of context, you can protect all of the term definitions within that. And that prevents any further attempts to change them to fail. So in the first case, we have context with two contexts. The first protects term name. The second attempts to. And as an alternative, we also can have a property within the body of the document knows introduce its own embedded context. And here it would attempt to set the context to null, which means go back to the ground state. That would also fail. And this is important certainly for accidentally, but it also avoids some potential attack vectors. If, for instance, you have a verifiable claim and you're verifying some data, you don't want two different processes to misinterpret that data because there was an attempt to override a term used within that data. Import is, I think, fairly obvious within a context. I can import that basically dereference that context, makes all of the things that are described in there attributes of this context, but the things that are local override, which is in the imported context. This allows me, say, to say that within a scope context, a type scope context, which would otherwise not be propagated, I'm going to take stuff from a remote because that was defined, say, before 1.0, but cause it to be propagated later on. The import mechanism might be used in a future specification for things such as sub-resource integrity. One pain point for many is the fact that contexts are dereferenced requires going out on the net, and there are some other schemes to attempt to avoid that, but one thing that's being looked at is sub-resource integrity, which could allow you to transmit contexts in the out of band and then make use of them and know that they are the appropriate context to use. HL data extraction is, of course, been normalized, and I talked about this. It's using quite a lot of features. One thing to note is that a new pattern, which my processors don't currently conform to, is the ability to inject JSON-LD into HTML. So you might use a tool which injects a JSON-LD within the DOM, so that to properly extract the content, you really need to evaluate the DOM. And this is something we're seeing more and more in the wild, and I don't expect our specs to treat that, but it's something that you should be aware of. JSON Literals. JSON Literals, you can see how they are normalized when they are turned into a literal, which means that they can be represented using white spaces within JSON or potentially within some other syntax as well. And it uses a RFC for doing the canonicalization, so that you can get some expected representations, say of integers or doubles when you might expect those. Directional text, as I mentioned, is something we've added into JSON-LD 1.1. So in this case, I can say that to treat default values as being, in this case, AREG, language AREG, and direction RTL. So when I see, say, the title, that would be a processor would know that was to be treated as right to left. There's a couple of ways of expressing this. The most favorite way has been to use this IATN namespace. So we create a data type composed of the language and the direction with some normalization, so that in this case I have a literal for EX title, which might otherwise just have a language, but now has a data type which expresses both the language and the direction. Of course, this works with Sparkle, Turtle, or other syntaxes, but is not an official spec, and it's just an informative description for a future working group perhaps to take on. And Andy, if you're listening, perhaps Sparkle 1.1 might look into this. Content negotiation, as I mentioned, we introduced the ability to do this link header. In this case, if I have a link rel alternate with type application LD plus JSON, a JSON-LD processor will, instead of looking at the content of this document, will dereference that alternate representation. And this is the primary means used for getting to the schema.org context today. Included nodes, taking some more riffs for how what is used in the wild. There is a specification, a JSON API, which describes the ability to describe other non-related or non-directly related nodes when returning data. We have a pattern using the included keyword. This is very similar to the use of @graph in some limited cases, but does not take on the added means of interpreting it, potentially interpreting as a named graph. YAML-LD, I can't really show CBOR-LD too well, but you might see how this works. You can easily round trip between JSON and YAML. Therefore, you can go from YAML to JSON, JSON to JSON-LD. Framing, let's see how we're doing for time. Oh, I guess we're running out of time. I'm going to briefly go through the rest of this. So framing, I'm not going to talk about this. There's a whole spec on it, and it's a program by example where you have a document with another document which tells you how to frame that, and frame matches that to recast the initial document otherwise. There's a number of keywords that are used there. We describe how you control embedding and some additional means of describing the way that you match nodes to be framed. So again, not much time to go into that. There's also a note on how we might respond to JSON RDF star for a JSON-LD star, and how JSON-LD might look if you are coming on from a notation 3 perspective. Okay, I will now stop sharing if I can. And I'm going to hand it back to Marco.
Wow, thank you very much, Greg. Can you hear me?
Yeah.
Excellent. Thank you very much. It's lots of content. I also told people that they can find the slides on the Lotico landing page. And that concludes the presentation. I would like to now take some questions from the audience. There was actually one already. Let me just pull it up. That is a question from Jarno Vandriel. And could you please unmute yourself and ask your question, Jano.
Hi, good morning for you guys.
Hey, Erna.
I noticed in the presentation you were talking about the poor man's reference for alternates in regards to the HTTP header. And I was wondering whether it's also possible to do the same within the HTML with a link element. Or is it just HTTP header?
It is actually just HTTP. So doing it with an HTML would require a JSON-LD processor to be able to parse HTML, which is something we wanted to avoid. Here you only need to look at the HTTP headers. So we do not describe a way of doing it using something like an equivalent.
Okay, thanks.
Okay, please raise your hand if you have a question. Actually, you can raise your hand electronically with the Zoom interface. If this doesn't work for you, you can just unmute yourself and ask a question, please. So while we wait for questions, I'd like to thank you, Gregg, for mentioning that this is not a versus JSON-LD versus Turtle effort, but that these are more or less complementary activities that work together. So we will continue to use Turtle for RDF representation, but these are specific features here that can be used within the JSON-LD framework that are quite powerful. I really like the text feature, the right to left indication for the annotation of text. You know, I'm surprised that we didn't have that already in Turtle or in RDF and any other serialization. That's quite useful. So questions, please.
Okay, I will have one question.
Gregg, yeah, please go ahead. Yeah.
Actually, I'm a kind of user that uses both JSON-LD as a completely separate and as RDF stored in a triple store. And the problem that I encountered with both JSON-LD and other types of RDF is regarding the missing data type that I would like actually to have, which is a key value map. So obviously, with the JSON object, you could store things like, let's say, prefixes and the namespaces as a kind of a key value map that I'm thinking about. But obviously, it misses then the point, and storing something like that in a triple store, I wouldn't have access to the data. And the other alternative is simply treating the key value map as a resource, as a node. But that also causes storing this information, let's say, in JSON-LD is not really clear and is, well, you could say it's actually ugly. And I was actually thinking if there is a possibility of, first of all, adding a custom data types to JSON-LD, and if something like a key value map would even be considered in the future for a JSON-LD specification.
Yes, well, so the data model for JSON-LD is RDF. Using those mechanisms with an RDF, you might represent keys values. I believe that schema.org defines a mechanism similar to that, and there is a mechanism I didn't talk about with ID maps and type maps. You can actually have any arbitrary property can be interpreted as a map. So that's something that might be useful for describing key values. So if you have a property, the values of those properties might be described within a map using that mechanism. There are, again, some examples in the spec. And if there's something more specific about that, we might have a conversation. There is a JSON-LD.org GitHub page with issue tracker, and that is where we are looking at future requests and is a good place to collaborate over potentially future things we might do with JSON-LD.
Okay, I'll try to write it down and possibly post it as an issue on the GitHub page, and then, yeah, then we'll eventually have a conversation. Thank you.
Thank you for the question, Greg. Okay, more questions, please. Okay, so then let me ask you the question about the future. There was a discussion about having literals in the subject position. Is this something that you consider for JSON-LD 1.1?
Well, that gets down to the data model, of course, the RDF data model. Well, I take that back. RDF has the notion of generalized triples, and in a generalized triple, any resource type could be used in any position. For instance, a literal could even be used as a property, but we don't currently support that. There is some work if you look on the slides online at the at the JSON-LD star note that we are working on. We show the ability to have the value of that ID itself be a node, which would allow you to then have a triple as a subject. You might imagine, if we've gotten to that point, that the value of that ID could be a value object, so that there are ways in which that could be done. And also, if you look at the next to last slide on as in doing logic programming in JSON-LD, it basically proposes a way of interpreting JSON-LD using the notation 3 data model, which is itself an extension of the RDF data model, which does specifically support literal subjects. So I think that type of thing would be in line with work we might do there. But the topic of literal subjects has been contentious in RDF for some time.
Every discussion is, every extension now. Questions, please. Okay, if there are no specific questions, oh, excuse me, Phil has a question. Please unmute yourself. And
yeah, thank you. I noticed when you were giving your presentation, Greg, and thank you, it was a great presentation. You mentioned that blank node properties have been deprecated in version 1.1. Could you explain what these were?
Well, so if you were being sold on using JSON-LD over some other type, which was certainly something we were very concerned with in the 1.0 timeframe, and the limiting factor was you needed a controlled vocabulary to be able to describe the properties and types that you use. We didn't want that to be an impediment. So we provided the way to use the @vocab key within a context, which would normally be a URI which used as the prefix for expanding properties and types. We allowed the ability to use a blank node, which would mean that if you didn't define a controlled vocabulary and you had something like name, the algorithms would work, that it would expand it to a blank node, which would syntactically have the structure of whatever you used as the base, and then appending the property name. And this allowed you to round trip through most of the algorithms, but notably not to and from RDF, as there is no guarantee that an RDF labels will be reused, and certainly doesn't work well if you're looking at merge semantics and things like that. So by deprecated might be too strong a word, perhaps made obsolete. It's somewhat like RDF reification, triple reification. It is somewhat obsoleted by named graphs, but is still in use, and RDF XML still uses it. So it is still usable by JSON-LD as well, but we do not encourage its use, and hope that a future version of activity streams, for instance, will do away with it.
Okay, that's great. Thanks very much. I'm reassured that I don't think I ever used them.
Yeah, unlikely unless you're using activity streams.
Well,
But it still can be used, and they will not, certainly before any 2.0 specification, would not expect them to be removed from the spec.
well, I think the idea was good, right? I think initially because it is the way a developer would naturally think about the data structure in a JSON object, like is similar to a property graph. So I think the idea was actually good. It was intuitive initially, but it's obviously not necessarily easy to deal with in RDF. That's,
Well, blank nodes are sort of the third rail in RDF in many respects, and people would love to do away with them. There's active discussion for how do we get rid of blank nodes, by which I think we mean how do we get rid of the need to explicitly use blank nodes. And mostly you don't need to in JSON-LD, but in particular, when you flatten a document, we do have to use blank nodes. But you really do not need to use blank nodes as part of the vocabulary namespace. But it's there if you have such a use case.
Okay, more questions? Okay, I think if there are no further questions, we will conclude the official part of the session. I will stop the recording and we open it up to everybody in the after session chat.